Okay, so again, good afternoon, everyone. Welcome to this webinar. So this will be the episode 2 of our webinar. So I will be starting my presentation. So let me just. So our episode 2 is interoperable workflows between Archicad, MEP, and Allplan structure. So from this episode, actually we were going to demonstrate you on how using the MEP from the Archicad will be collaborated with Allplan, especially on the precast side, wherein we will incorporate the necessary openings or recesses for your precast elements. So for the next slide, so our agenda will be about the GSI. Then we will be followed by the industry context. And then, of course, the agenda 3 will be interoperable workflows between Archicad, MEP, and Allplan structure and our demo. And then we will move to the Q&A session. So for our introduction about GSI, so in GSI we have already 4 offices. We're located at Vietnam, Hong Kong, Singapore, and of course in Germany. And we have 8 operations active across APAC countries, and then 40 plus dedicated individuals representing diverse backgrounds committed to exceeding your unique project goals. So we have personals who will support you on your projects. So after below is our contact number. If you need, if you have some questions, or you can reach out through these numbers, and also the email. Our key services is actually, as you know, we are an authorized partner of Allplan. We have also the Bluebeam, the Freelo, Graphisoft as distributor. We also have the Solibri and as well Idea Statica and Sophistic. So we are, I can say we are a company who can support you on your different needs on your projects. So if you want to have an appointment, you can just scan the QR code to book your appointment so that we will help or guide you on your needs. So myself, I just want to give my introduction about myself. So I am Jayson Panganiban, a technical specialist for precast of GSI Group, with 13 years of experience in precast industry and a lot of projects handled in Singapore, structural projects, especially in precast elements. So if you want to get more information or you want to have a chat with me or ask some support, you can just scan the QR code shown in your screen, and also you can email me from this email address. Together with me, who will be demonstrating also in the Archicad side, let me introduce to you Mr. Sudhir Thapa.
Hello everyone.
Hi Sudhir, good afternoon.
Hey Jason, good afternoon.
Yeah, so I will just transfer you my screen. Okay.
Sure. This is me, Sudhir Thapa, Customer Success Manager at GSI Group, and if you want to contact me, you can directly email or scan the QR code. So without further ado, I would like to start with the next slide. So if you have any questions, you can use the question panel in the GoToWebinar app. So feel free to just fill in the questions in the tab and we will get those questions running. So before we start, I would also like to introduce the NMSCheck group, which is the umbrella organization of various planning and design softwares, the building and construction, operate, manage, and media and entertainment as well. And as for the Graphisoft Archicad, it's a BIM software used by hundreds and thousands of engineers and architects worldwide. It has the capabilities of architectural modeling with MEP and structural modeling in place. So it was an organization formed in Hungary, and now it's a part of Nemetschek Group. So the Archicad can be used in multiple design phases, starting from conceptual design to your construction documentation. On the next slide, we have Allplan, which is an infrastructure software with precast functionalities, multiple projects such as large projects where we have the design to build workflows. Customers can increase their efficiency using Allplan. On the industry context side, as we also discussed in the last webinar, Jayson and I had a good conversation on about what the context is currently in the industry. So the design coordination between the project team is really necessary and basically is essential for limiting design issues and construction site risks. So in the construction of any infrastructure, the coordination between architectural design, structural engineering, and MEPF systems is crucial for mitigating the construction site risks, and also it ensures project success if we coordinate. So for an example, just let's imagine there's a building project where there's this architectural design, which is like floor to ceiling glass windows, a high-rise building. And for the high-rise building, the architects have designed the glass in sort of a way that it maximizes the natural light and it gives the panoramic views. But in this case, so without the effective coordination between architectural, structural, and MEPF team, this project may face a lot of risks. So in structural stability, basically the installation of large glass windows as proposed by the architectural team. So without the proper structural support, it could pose a safety hazard. On the MEPF side as well, the integration, if there's a poor coordination, then the designs may result in inefficient layouts. The clashes between the systems can occur, and costly rework to accommodate essential utilities such as the HVAC ducts, the electrical wirings, and plumbings. So also on the fire safety side, the failure to address the fire protection concerns early in the design process could also lead to inadequate emergency exit options, also to reduce the fire resistance, and non-compliance with building codes and regulations may occur if there's no coordinations. So to basically overcome all these challenges and ensure the project success, we as a design discipline teams, multiple teams must be proactively collaborating and communicating. So this involves conducting interdisciplinary design reviews, implementing BIM workflows and technologies for clash detection and coordination, which fosters a culture of cooperation and problem solving. So Jayson, do you have a say on the problem statement, which we can also talk about currently as for the closed BIM approach between these disciplines, architecture, structure, and MEP?
Yeah, actually, thanks for that. Well, based on the experience what I've had before, when we're working with the MEPs, well, the problem is because the precast elements are the, let's say, the end product of the project. So basically, what we need to know is like the exact information of the MEPs. Let's say if they have recess or they have embedded fixtures, we have to know it in the let's say in the earlier stage in order for us to really produce the elements on time. So what we face normally is that there are times that there's no proper coordination between different disciplines. So basically, the MEP will be the always, not always, but most of the time will be the late. Let's say they are the last, or how will they submit it will be the last part, something like that, because they have to confirm it with the architecture or others, other disciplines. And then when we're going to incorporate this on our model and our precast elements, then there are cases that we already produced the elements because we need to catch on the production of the elements on time. So there are cases that we need to do some hacking in order for these MEPs to be placed on the correct location. So that was based on my experience and always the problem that we're facing when we're incorporating also the MEP project. So as you said, without proper coordination of different disciplines, then of course these problems will always exist in every project. Yeah.
Yes, for sure. So that's why we have the open BIM here now. I
Yes.
would like to touch on the open BIM slide as well, where we talk about the industry foundation class, which is the ISO standard for the data exchange between the uh, various stakeholders involved in the construction industry. So Building Smart was actually developed back then in 1994. It's a company developing IFC, and basically the IFC files saved in any given time can seamlessly be accessed without issues. So it can also be used as an archival information, let's say. So you can access your older files if it's saved in IFC. So any versions of IFC can be opened without having any issues. So basically in the open BIM, we utilize the industry's foundation class and do the model exchanges. So now we start with the webinar's actual core part, where we will be basically talking about firstly the general workflow, and we will have the demonstration in Archicad and Allplan, where we will also seamlessly integrate those design changes between MEP and structural. So this is a demo stage where we have from 1 to 6 where we will do the demo. So 1 to 3 will be done in Archicad, and 4 to 5 is on Allplan, and again on back to 6, Jayson will pass me the model and I will do the stage 6 demonstration. So moving on to the general workflow, we have stage 1 to 6, as I said earlier. So stage 1 is pre-design phase, 2 is going to be the model preparation in Archicad, 3 is going to be MEP model routing, QA and export, 4 is the structural elements import, design and adjustments, stage 5 QA, model export, and 6 import, verify and model sorting out. A bit more clearer view on stage 1 to 3 is on this slide. So stage 1, we have the pre-design phase where we have a sample model already ready. On stage 2, we have the Archicad MEP model preparation, where the templates are already ready as well. Basically, starting a project, it always requires you to have a correct template, the attributes, and the material libraries all set up. For this, MEP library as well. On the stage 3, we will be doing the BIM modeling phase, where the MEP design will be clearly modeled as per the requirements. The MEP routing will be used in Archicad, and once that's done, the QA will be done and the model will also be exported towards Allplan. Okay, so without further ado, let's start with the demonstration here. So I have a plan that's set up here where the layers are on. The layers can be seen, which is going to be the combination of architectural model and MEP. So if I closely zoom into this parking section here, there's a conduit running out. This is the MEP we have here, and the rest is the architectural model. So if I try and select the MEP element here, it has a lot of settings that I've already set. So the system is placed on cabling, and we have an offset from the home story. We have these floor plan and section views where we will basically it's saying that Archicad is using these symbols and floor plan display settings. On the classification and properties, currently it's unclassified. But if we want to have the IFC workflows, we basically have to classify our elements properly so that the design teams from other disciplines can receive them and understand what the element is exactly about. So this is basically a cable carrier segment. Also, the IDs and properties are also very important in this basic element right here that I selected. The element ID of this route, cable route, is cable carrier route 007, but it can be adjusted as per the need and requirements. So on the segment side, we have various settings already placed here. The dimensions, the cable carriers, will it have a cover or not? We can turn on and off the cover. On the elbow side, this is going to be the elbow. So any intersections between two segments will be basically the node will happen as the elbow. So elbow settings also can be much more advancedly, basically adjusted. So we also have the transition here. The transition can also have the cover or not have the cover. We can fill in various descriptions for this particular transition. We have the option to also fill in the user-defined descriptions. We can have the individual transition to be as classified, and also the IDs could also be set for the particular transition. But as long as we have the basic cable carrier route here all set with the classifications, we are still good to go. The other ones are going to be much more in detail, the segments and nodes. So currently I've only set the properties for the main cable carrier route, which will cover all these elements. And the layer system is kept at M&E electrical. So the routing options, basically for this webinar, I will simply just use the design tab where the MEP engineering tools lie, just to showcase how I placed those routes. So if I have this cable carrier route selected and I start to model from over here, let's say, it gives me an option. Okay, before I place it, I need to put it in the right layer as well. So I can go up here and quickly do the electrical. and then start placing it. So this is the plan view. So I can do this plan view here. So as we discussed earlier about the node, it automatically places the node as per the settings we have set earlier. The cable carrier has been placed on the plan view, and now I'm going to view it on the 3D view. So this is the 3D view. So we can see the cover is not placed, so we can select that and go back in and try and place the cover as required for the elbows and also the transition. So once that's done, quickly the cover appears. If we want to show every model, I'll just try and show all. So let's say for the example's sake, now the route has to vertically go downwards. So to do that, I can directly use 3D view and make use of the tracker to basically model the elements. So basically we can model those cable routes, HVAC duct routes, plumbing routes in a 3D environment just by using the tracker. So as you can see in the screen, the MEP models are basically modeled in the same manner. I have the electrical fixtures placed as well. We can use the object tools or lamp tool to find the elements that we require in the library. So let's say if I want to find any lights, I'll just hit on say lights. So as per the need of the light, we can select those here. Or if you have your own material object libraries, it's even better. You can have your own materials loaded. And once that's loaded, you will have to select the lights that you need. All those settings here you can see with the intensity, the distance, width of the geometry, all these can be set in this interface. The current view that we are seeing has a graphical override powered on, which basically highlights the MEP elements and the other elements such as the architectural model and structural model, they sort of phase out or have a X-ray kind of look so that you can actually see through the walls and the doors, whatnot. The elements which we can currently see here, the piping elements, it's basically for the plumbing. This is also done exactly the same way using the MEP engineering tools here, the Pipeworks. So now, once the stage of MEP modeling and routing is done, basically stage 1 and 2 are already done here, so we did not really see that happen. But stage 3, we sort of had this idea on how to route the cables. For the stage 2, if I really want to add up here, I can see that we can talk about a little on the library. So the library manager is basically present in the file option here. And basically we can load on these libraries that we require. So Archicad already has the migration libraries given, and also for the sample project we have this library all set. And if there's any extra libraries that you need, then you can go ahead here and add. So select the add link library and basically find your library and add it. So now for the QA and export, as I said, we use the graphical overrides to check for the layers, to check the other visibility issues. We can check the layers of every element that's present here. We can see if the elements are having the correct classifications as well. If any element is placed on a wrong classification, we might want to adjust those before sending it out to other design teams so that there's no confusion. Let's see if I can find a classification for this light. Okay, for this light, it says light fixture already. So basically, it's placed on the right classification. So now once that's done, we send out this model to the MEP team or the structural team as well. We just send the latest design. So if I just want to send the MEP elements only, I quickly switch over to the MEP layer combinations. And once that's visualized, we can go ahead and do the save as function. So I would like to show you the translator options here, which is currently on a general export mode. So all these settings here, the model view definitions, the IFC schemas, the filters, type mappings, and so on, these are already set. So for this, we will just use the general export. So the model has been exported. Now I would like to invite Jayson to showcase you how the elements are going to be brought back into Allplan, and the recess and all that stuff will be demonstrated. And it's going to be quite interesting to see from his side as well now.
Thank you, Sudhir. Right. So basically now you already exported, right? So I can share now my screen.
Yep.
Share my screen. Sharing. Can you see my screen now?
Yes, Jayson, it's visible.
It's visible. Okay, great. So after the stage 1 to 3, now we move on to the stage 4, wherein we will import the B model from Archicad to Allplan. So that is the MEP that was exported by Sudhir. So from there, we will do the, I will show you the MEP functionality for precast, which can generate automatic recess on the element. Then, of course, with this automatic, it will also adjust the reinforcements and, of course, the shop throwing changes. And then we will move to the stage 5, wherein we're going to export the structural elements back to our Archicad so that they can do the assurance or quality check on the elements. So I'll share my other screen. Okay. Yeah, you can see my screen now, right?
Yes, Jayson, it's visible.
Yeah, thank you. So here, I already imported the MEP from the model of Sudhir. So basically, these are the MEPs he modeled initially. So this is the one he's discussing with this cable tray here, cable racks. And of course, we have these kinds of ducts that will be passing through the slab for the next level. So basically, if I'm going to show you something like this, so I will have a slab here. So later on, I will change this to a precast slab. And then from the model, previously on the episode 1, so I have shown you that we have these walls wherein we created them as precast elements. And of course, we have placed them some reinforcements. So basically, you can see here that there are um, there is this thing inside the precast wall, and of course for the slab. So first, I will show you how it would interact with these precast elements and how we can generate the recess using this imported MEP. So let me just say I will remove first those unnecessary things here. So I will just remove this one, which is the slab, and not this one, but this one, so we can see it more clearly. So for this case, this is the only part where it goes into the precast element or for the wall. So this is where we're going to focus now. So here. So what we're going to do is just we go to the precast wall, and then we have this functionality of MEP wizard. Wherein once we do click this one, you have two options, two objects that to be selected out. Is it either smart symbol or you have the 3D objects? So basically, we have here, let's check. We can select this and you can see it's a 3D object. So we can use this as a 3D object. So from this, for this case, we will provide a recess for this precast element. So before that, I can show you that we can, as I mentioned before, we can easily generate the shop drawing of it. So we have this shop drawing. So here is the sample, the shop drawing automatically generated. So I open this one so that you can see how interactive or how they synchronize whenever we do some changes. So I will just leave this open. And maybe I just close this part so that they have a better view. So what we're going to do now is we click this MEP wizard and then select these 3D objects, and I will select the component, which is the precast element, and then we'll ask to select the MEP objects. So I will just select this part, and as you can see, I have this 3 elements. If I click on this one, it highlights which object you are selecting, this one or this one. So basically, these 3 are the elements touching my precast element. So what I'm going to do is that I want to change, or I want to make them or provide an opening to this elements so that whenever the MEP comes in, they will just place this on my precast element. So what I'm going to do is just click on these three dots and I will just select parameters. So here I can say that either rectangular based or rectangle based on center, then rectangle, circle based on center or circle. So maybe I will just use the rectangle here so that it will detect the perimeter of the object and it will offset based on the perimeter. So I will just exaggerate. Let's say I want to have a 50 gap from that object. So once I select OK and then run, so these are just for the bars, as you can see from the bars. So here, it gives you automatically the recess. You can see from here. Let me just zoom in. Okay. So you can see here that I have provided a recess. And from this recess, you can see that the bars are automatically cut out. Okay, so for this case, you can see that this bar was not cut. This is because this bar acts as the holding bar for this part. So of course, on the side, you can just cut this if it's really needed to cut. But for the other bars, it was already cut out. Okay, so this is how your MEP wizard works. And of course, once you do the changes, as you can see from this part, you already have your cutout, right? So you can see from here, there are cutouts. So if I go back, if I go to my reinforcement, which I have here, so as you can see, there are some parts that has lines here. It means it was cut, as well as these isometric views shown. Okay, so this is how the MEP works. Now, basically, this is not only for cutouts, but it can also be, let's say, we want to embed this fixture inside the precast element. So there are cases, let's say, I want to say copy these elements. So I will just do copy and move somewhere here. So let's say I provide on the y-axis. So I want to provide distance of 2.9. So I will have another, let's say, cable here with the same socket, but I want to embed this fixture inside. So what I can do is that I will do the same process. So I will select this MEP wizard, select the element, okay, select the element and MEP wizard. Yeah, okay, so I will have the same properties, but instead of the opening parameters, I will just use the fixture parameters. So basically, I will just need to see which one I'm selecting. So maybe I can just select this one and then fixture parameters. So I will select from my library, and let's say before that, oops, sorry. I just want to show you that from the object we selected will be this. So we will replace this with the whole part of the cable, including the switch. So let's try to select which one, project, webinar, elements, MEP, and then we will replace that one with this fixture. So it's one object already. So I will just say okay. So from here, I will just rotate this and adjust based on the location, correct location. So this one I will just adjust. So this one is pre-calculated. So just to make our time less, so I will just define the location and I will just say okay, and I will just run. So as you can see here, nothing changed because it's still the same place. But if we open the shop drawing, As you can see here, it gives you the fixture. It places the fixture that you have created. It's this one. Okay. So basically, it's not only creating recess, but also in placing directly your fixture, we call it fixture, or your MEP elements. So to see it in an isometric view, I can just have to say close this drawing, and then as you can see here, I just remove the view. Let's just remove the view and open this. So as you can see here, it is also inside your precast element. So maybe I can just say remove this, no, not this one, but the walls. Uh, yeah, this one I think we can select this. Yeah. So this is how we can select the object inside your precast elements. So let's say there are cases that, hey, you need to shift this by only 2,800 from the other one. So what I can do is that I can just say move this, the one I copy. So maybe I can just say move, not this one, but this one, move the object. Of course, we can move it on directly on the picture that we placed, but we want to move this element, not this one, but the rest. So maybe I can just remove it first. Let's try to remove it first. I don't want to see it. So I guess there's no more, right? So what, let's say I want to move this part or this one, better this one, the recess. So let's say I move this part maybe another 200. Maybe the location was wrong. So what will be the effect? So your precast element will be already wrong because your recess will be here. Using the MEP wizard, we can just say select this MEP element and we just rerun this, and you will see that your recess will adjust based on the new location of your MEP. Same as what we did here. We can just change the location of this and it will automatically shift your fixture. So yeah, this is for the wall. Okay, so we can just move it back. Okay, and then we move now to the slab wherein we have this ducts here that is passing through this slab. So we can say I will just need to open my slab. Okay, I have to open this and then make this as my default. I will just open my reference, and I can just generate the slab here. So basically, what I'm going to use is a precast slab, like what I've shown in the episode 1. Select the design, and then I will just select the boundary inside. So I can say, yep, I have to select the boundary. Normally this should be okay. So let's try to have this. And then, we don't want to discard. And we just say okay. So basically I have this. We can provide cutouts. So we need to have this cut. What is the size of this cut? Let me measure. So from here to here. It's about 250. Okay, we can just say provide reasons. Then we can just define this. What happened? Okay, let me try again. I cannot find releases. I have to change this by what size? I forgot. Try to measure again. This is X to 150 and 3540. 150, 3540. 150, 150, this one 3540. So we have this now, and then I will just select this part. So I will have my pieces. Where is it? Let me check. Oh, okay. This is my slab pieces. So from here, I need to shift my model, but before that, I need to check if it's in the correct level. Yeah, I have to shift my model. So let me shift them down. Look, where's my reference? I have to open them. So I need to shift this to this level. So basically, I just need to fix my X. Then this also slab braces. I need to fix X somewhere here so that I will have my opening. Okay, delete this part. Okay, now I have this and I need to have my duct here. So I will just open my slab and then my duct, which is the other one. Okay, so here it's passing through my elements. So I don't need this part. This one is part of the, you can just ignore that. So what we are focusing on the originals for this part. So I will do the same using the MEP wizard, and I will select my element and then select my, where's the dot? It should be, oops, sorry. Okay, let me do it again. Select the element and then the MEP. So I will just have to select this and I will provide the opening. Of course, it should be an opening because it's a dot passing through. So I will just use rectangle and maybe change to 50. Say okay, and then run. So as you can see from here, my slab reinforcements also cut. My slab has cut out based on the parameters that you provided. So it's a 50 opening, 50 from the edges of the object. Same as what we're going to do here. I will just select the component, select the MEP, and I will do save parameters, and then say rectangle 50, 50, 50, 50, and then run. So basically, you will have this opening as well on the other side. And of course, shop drawing wise, what you have seen from the slab, it's also the same. Maybe we can try to create a slab here. Let's try if this will work, because I didn't change anything here. But of course, you can see here, it has these faces or opening with the that is girder cut, and of course the reinforcement as well. So it automatically generates the information you provided. Again, if we move, let's say we move this object, let's say move this from here to, let's say, y-axis about 500. So let's say your MEP change Of course, this recess needs to update. So what we're going to do is we do the same. MEP wizard, select the object or the element, and then the MEP object. And then here, instead of this, you just have to rerun, and automatically it will adjust on the new location for your MEP. So it will give you the proper dimension. Okay, so that's the power of the MEP wizard. So what I'm going to do now is the stage 5, wherein I will send this by exporting the IFC model to Archicad, back to Archicad. Only these slab elements and the precast wall by exporting IFC, and then I will have to select which element. So it's the wall and the slab, and I will just say OK where you want to save it. So it will give me on this part, which I already saved it. So, and also already sent to Sudhir. So that ends for my demo presentation. If you have any question, just feel free to type into our Q&A box, chat box, so that we can answer your questions. So from here, I'll pass back to Sudhir to do the stage 6. Hi, Sudhir.
So now that I have the model from Jayson, this is going to be the basic workflow for the next demo. So the models can be basically imported from other disciplines, and these can be either used as a reference or it can be merged into the model for direct output. So by referencing a model, we duplicate the elements, and the elements are to be handled independently by each discipline. So this gives a better control over the drawing output. However, if we have the models and get them merged inside Archicad, then it is basically much more time efficient, and it also results in less repetitive works. Although this requires much more trust between the disciplines. So basically, while receiving the model changes, if we merge them, we need to make sure that the disciplines have sent us the latest file and everything is well discussed before having those files merged. So both of these strategies, referencing the model and merging the model, have consequences in model performance. So we also need to take this into account as per the team's hardware capacity. So in this workflow, we will check the model, verify if everything is correct or not, and create the design views. We will also use the compare function in Archicad to just sort of compare the models of before and after views, and complete this webinar. So while we are on the demo, we will have this view where we can see what Jayson had exported. So the new destination for the cable routing fixture is visible as a pink graphics here. So the element has been also placed over on this side. The recess is over there for the existing cable route. And the graphics has set as you can see, the red ones will be the non-load bearing elements, and the gray one is the precast element, which is load bearing element. And there we go. So all the elements that were placed in Allplan now are seen in this file here in Archicad as well. So we can see that the rebars are visible, and the cable routing can also be visualized here. So we can visualize its settings as well. We can adjust the properties as needed. If we quickly try to see this in 3D view, we can do that using the marquee tool. So this was what got sent from Jayson. So if we use the graphical overrides for visualizing the elements clearly, we can see that it's highlighted over here. And if we want to filter out all the elements and show them, it's also possible. So as I said earlier, the red ones are non-load bearing, and the gray one is going to be the load bearing elements, which is clearly visible. So this is the ground floor that we are viewing. And currently on the post 3D view, we have to still set up the layers correctly. So this is the view that we have here currently. So adjusting also the architecture with post-structural elements, we can update those. Have these ready. We can have the elements highlighted. So moving on to the model comparison feature here. So if we go to the design tab and start with the model compare. So I'll currently select the model that's open, which is the post 3D view. And the model 2, I'll also select it to be the current one, and then go to the view selector. So the view selector is powered on after we have these models selected here, and then we can individually select them. So currently it's on the apply common view settings, but we do not want that. We want to have different view settings. So one is going to be the before view, and the other one is going to be the after view, so that we can check it out on what's the differences between the before and after. So I have these views already made ready here for the ground floor, before ground floor, and after. So if I hit compare, it's going to compare those two models. So you can see that the red one is the before and the blue one is the after. Since Jayson sent me the updated file, it's basically the after view, and it's clearly highlighted here in blue. So the design teams can understand where the changes have happened and quickly zoom in and just focus on those changes. So I think that sums up for today's webinar. We took a little bit of extra time from you all. We apologize for that, but I hope you had an interesting time here with us in the webinar, and please send us any questions that you have, and we'll start answering those.
So we can spend some time to wait if they have some questions, right? While waiting for the Q&A, do we have any other new or upcoming webinars that you want to promote?
Yeah, the upcoming episode for the same series we will have is with With the same model, Jayson and I will be preparing another webinar for you guys to watch. So we will sort of take a deep dive into perhaps the clash detection as well. And also on this other episodes, we sort of want to demonstrate the Archicad and Bluebeam workflow. So Bluebeam is another software that's really useful in the BIM workflow, which we can test out with the authoring softwares that we have. We will test those out, and hopefully we will have you guys entertained and have you fascinated by the open BIM workflow.
Yeah, so these are our social media platforms. So you can scan the QR codes and then join on these groups, and then you can be updated of our upcoming webinars or other information regarding the softwares that we're incorporating on these webinars. Okay, so thank you so much for your time. I hope to see you again next time. Sudhir.
Yes, thank you. Thank you for having us all. See you next time. Yeah, have a good day.
See you next time, guys. Thank you. Bye-bye.